Hello, everybody. My name is Aurika Savitskaite. I'm a co-founder of HelmetBasedVentilation.com. Today, I have a pleasure to interview a great team from very location independent, actually. We have here Wayne. He's the leader of the Charge Concepts, and he's a leader of a team who are developing some of the accessories for the helmet-based ventilation. So, Wayne, why don't you introduce your team members and tell us more about your mission?
Sure. Arika, first and foremost, thank you very much for having us. We're really honored to get to work with you in helmet-based ventilation, and then introduce our team and our work. So first, a bit about Charge Concepts. We are a group that has a lot of biomedical experience, but we're a global multidisciplinary team consisting of engineers, designers, nurses, physicians, doctors, regulatory experts, VFX entertainment specialists, as well as other subject matter experts that are coming together to solve problems and look at what doesn't currently exist in the space. Our team believes in collaboration and coming together to bring these passionate concepts and turning them into impactful programs, technologies, and initiatives. With me, I have Travis from Helium, as well as Evan Weinberg, who is a teacher at South Saigon International School in Vietnam. So this gives you an example of the truly global approach to this global pandemic and war that we're fighting. So before I get into more of what we are doing, let Travis and Evan give them a bit of their background as well.
So again, my name is Evan Weinberg. I'm the secondary STEM coordinator at Saigon South International School. I graduated with an engineering degree, but I have actually spent my entire career since graduation in the classroom. I'd say as now that I'm in my 18th year, I find the classroom a really great place to get students interested in real life problems. And some of the stuff we're going to talk about today is a perfect example of the kind of thing that students can get involved in. My excitement and my enthusiasm for technology as a problem-solving medium is something I share with my students, and it's something I've been recognized for. I was acknowledged as an Apple Distinguished Educator in 2017. I've been asked to run a bunch of workshops related to the use of technology and engineering and robotics in the area, and so it's been really great to be part of Wayne's team trying to solve this very important problem.
Hello, my name is Travis Teague. I'm developer growth lead right now over at Helium Systems, and working with companies that are using the Helium network, what we call the People's Network, to implement solutions. My background is computer science, electrical engineering. I've worked extensively with voice interfaces and with the Alexa program over at Amazon, as well as Google Home. And so I run those Slacks for the development communities over there as well. We actually just started rolling out and building this network this past August, and we launched down in Austin, Texas. And we now are in all 50 states. We've moved into Canada. We just released our EU hotspots and moving into Asia as well. And so this is the fastest growing network that I think has ever been stood up. I mean, it's a decentralized network that is built specifically for Internet of Things, for very long range, very low power devices, which, I mean, you can hit satellites, from a device this big that runs on a coin cell battery. It's decentralized in a sense that when you run what we call hotspots, you are part of the network. It's all built around blockchain technology and allows this to be decentralized, where we're not relying on AT&T, we're not relying on Verizon. It's something that really is owned by the people. So.
That's amazing. So this is where anyone in any part of the world have access to internet, to the knowledge, to education, and we can and actually this can be used for this some of the devices that you are developing. So we can talk more about later when you will present them. I want to ask any of you to present some of the products that you already developed for the helmet that is used for non-invasive ventilation. Maybe we can start with the Pruning Pillow, because this accessory is very important. As you know from Italians, early pruning for the COVID patients can bring good results and then survival rates. We're still waiting for some of the studies to be finalized and posted and published about that, but this is what they noticed back in March, that if you start to prune patients early, you have better results, better chances for that patient to survive, and less complications to develop.
I do want to also stress that we're designing these accessories to fill in the gaps, to increase the efficacy and the adoption. And this is where we hope to design accessories that are helmet agnostic, meaning that any of these different type of manufacturers that are producing the helmets, which we applaud and want to support and collaborate with, could potentially use these devices that we're going to show you, whether they be in sensors and alarms or in the pruning pillows. We're really focused on understanding the better expansion of the dorsal lung regions and how we might be able to allow someone to prone and remove some of these secretions to increase their oxygenation. So proning may be lying face down, but also may see the benefits of lying on the side as well. With the current helmets, sometimes this can be a little bit uncomfortable. The head is not necessarily supported. There's makeshift examples where they'll cut foam or they'll put a blanket that's folded up. So with this, we wanted to see where we could apply some of our expertise, whether they're in inflatables or design, to make different solutions that could be easily adapted, whether it's something that looks like earmuffs that can lie on either side, or a pillow that could be rotated, that when they're laying on their back can serve as just a head cushion or a head cradle itself. If we're flowing air and oxygen into this, could we take the inflatable man concept that you would see at a car wash or a inflatable bouncy house and utilize that airflow to be able to have something that could be deployed and retracted while being very minimally invasive in terms of space or not making someone claustrophobic? So these are some of the accessories and designs and concepts that we've been looking at. This last one on the bottom right showcases a pillow that can be moved with an external magnet so that it can be repositioned externally by either the patient or a nurse or doctor. And this is one where all the technologies that we're aimed at building are designed to try to make the jobs of the nurses, doctors, and caretakers easier. That allows them to focus and really get this technology to where they're needed so that they have trust and comfort. So the proning pillows are one aspect that our team is currently working on. Beyond that, we'd like to talk about some of the sensors and alarms, and this is where we found out that beyond running these in an open loop fashion where we're flowing in oxygen as well as hospital air at very, very high rates, we don't necessarily have the typical alarm systems that, Aurika, you might be used to as a nurse. And can you talk about maybe the importance, before we actually show you what we're working on, of why these sensors and alarms are important and how quickly a patient can go from a situation that may be favorable to less favorable?
Yes, Wayne. So thank you for bringing this up. So totally based on my experience as a nurse, as a patient care manager in the medical ICU, I can say that alarms play a very big role and very important part of your workflow. So what happens every day, and I don't know if any of you have had a chance to be in an ICU unit, visit somebody, you will hear a lot of noise, and this is what nurses are going through every day, and we can recognize different alarms, based on the tone and the urgency. Then we can respond fast to the patient. That gives you a peace of mind, because if alarms are working appropriately, you know that you're not going to miss some big events that can sometimes even cause life for the patient. So this is where sensors and audible alarms or visible alarms are very important in ICU settings, and not just ICU settings. So, for example, in ICU, you will have 2-3 patients. One nurse will have 2-3 patients that she takes care for 12 hours. And the rooms are individual, so you may end up in one patient's room when another patient is having some issues, and alarms will alert you, and alarms will inform you that you have to go to another room. Another issue is on regular floors. So, for example, if you are using helmet-based ventilation as a CPAP setup that was actually presented by Dr. Surita in one of our protocols, you will see that these patients can be on a regular floor. So that means one nurse will have 4, sometimes up to 6 patients. And without the alarm, it is very stressful to work on that unit. So we usually connect patients to the monitor, where we monitor their vital systems. But at the same time, you wanted to get the alarms from the machines that we are connected to. And in some places, they have no vital signs, monitoring capabilities. So that's, again, if you know that something is disconnected, it can be anything. It can be the IV fluids. If it's disconnected, it will alarm, or it will give you some note that you have to change the medication, it's empty the bag, or if it's ventilated, if it's disconnected, or if the patient is coughing a lot. So again, it gives you some audible alarm that goes in on a main monitor in the unit, or it goes to your portable phones. Some hospitals have those. So this is because helmet is very new for the US. You definitely want to make sure that you implementing this in a safe environment. So this is why University of Chicago Hospital, suggesting to use it in ICU settings only, because you have more eyes, more staff, you have more respiratory therapists in the unit, and also more alarms. But I know that other countries, underdeveloped countries, they don't have those settings in place. So this is where any alarm can help to manage the patient, manage the non-invasive ventilation.
We're not only designing solutions for the first world and problems here in the U.S., but we're looking at the second, the third, the developing nations that may not have the infrastructure, the resources, or the personnel may be extremely limited. So if one nurse is responsible for 2 or 3 patients here, you might have one person looking after 10 people. And how do you differentiate that and allow them to be able to not be sitting next to them at all times, right? And trying to take care of all of those individuals. So knowing things like, what is the oxygen concentration? Are the pressures appropriate in the helmet? What is the CO2 concentration? And at what point does it get toxic? And we need to make an intervention. Or allowing the healthcare personnel to make better informed decisions, to make adjustments. We're not trying to tell them what to do, but give them the tools and technologies to really monitor how the treatment is progressing. Make sure that we can work on the communication infrastructure, which we'll talk to you about, and this is where Travis comes in. Mm-hmm. And what are some of our abilities to learn from this? So this is something that we're envisioning solutions, and the helmets, non-invasive ventilation helmets, not just being a solution for COVID-19 and what we face currently, but for any future ailment where we want to have high flow, high pressure, elevated pressure oxygen, as well as containment as part of that therapy for any pathogens, whether they be a bloodborne, pulmonary, viral, or bacterial pathogen.
We as engineers get really excited about all the different things we could do. And I think it was some of our conversations with you that focused us on the fundamental issue, which is what you said. It's that idea of using sensors to trigger alarms. And this, the principles behind doing that is actually key to the classes that I teach. I mean, I have students writing control systems to trigger lights or buzzers or something to happen all the time. And this idea of using sensor systems to automate tasks is part of, I mean, in education, we talk about it as computational thinking, but in the bigger context, the reason we do it is to make it so that computers are doing the monotonous stuff of keeping an eye on levels of oxygen or pressure or temperature, as Wayne was saying, so that we as humans can take care of those things that we're really good at. And this is especially the case for the nurses and the doctors who are there monitoring patients. So the idea that we focus with some of your feedback was, can we trigger alarms when one of a number of environment variables go beyond certain thresholds? And so I'll just show you real quick a little fun prototype. So this basically is displaying right now the pressure, temperature, and humidity and the carbon dioxide level of things going around right now. I'm going to do my best to speak close to the CO2 sensor to see if I can get it to trigger while this is happening. This is the kind of thing that I have my students do all the time. You can see just from my breath, just from my speaking, I'm now knowing that I probably should stop talking.
Start breathing.
Right, exactly. But this is the idea, and the other piece of that is, while we're streaming data from this device, I'm sending it to my phone as well, just as a prototype of something we could potentially do to say we can take this information from the sensor and do something with it. And so this makes it so that a nurse doesn't have to stand there, look at all the different gauges, and make decisions themselves. Instead, they're going to be alerted to a situation that maybe needs attention. And this could be one of a number of different patients that might be under her or his care. So it's something that hopefully will make things easier for you and everybody as we try to address this fight. I'll just bring up, in Vietnam, we had a long time where we were doing really well. We had 99 days without community transmission, and 2 weeks ago, all it takes is just something to go wrong, and now we have a number of cases, and we're going back into another wave. We're looking to try to build these systems so that they're robust and flexible enough so that they work now and they'll work well into the future as well. It does seem to be a different strain. It doesn't match what was here when things first started back in March. So it is, this is an evolving problem, and it's something that all of us have to work together to get right. And there's something really special about the fact that when things were much better here and things are okay here, that I was getting information from Wayne to try to understand this problem. And while we were in a good place, we could do some experiments and experiment with this. And now that things are working, we can send that back and hopefully get in the hands of some nurses and doctors to be able to actually experiment, so that if it works, if things get bad here, we can certainly bring that back to the country of Vietnam and elsewhere.
Yeah, so you are lucky you had the time to prepare for that, and now with the pandemic still being here, and I can say definitely not gonna end this year. countries who had a chance to prepare and to delay that in their countries, they have better chances and better, survival rates for the patients. And now I want to go back. Actually, this is where Travis can talk a little bit more about the data collection, actually, about the, because these sensors, they, as Evan was showing, can communicate with the smartphones. And thanks to your technology, the helium system, you can actually collect this data, send it to the physicians or to any research teams where we can see the whole picture, and we can see how the helmet system works, how the patient's responding to that treatment. So can you talk a little bit more about that?
Yes, absolutely. Using this technology, which is called LoRaWAN, it allows you to have a very low data rate, but very long distance and very permeating radio signal, which means that inside areas like hospitals where a lot of times your Wi-Fi, 2.4, 5G is not going to be nearly as effective as these sub-G bands that allow you to have much better coverage. They allow you to have a lot better error correction. And so this uses a spread spectrum like chirp protocol, which allows you to work in very noisy or kind of radio dirty environments and still have very good end-to-end collection of the sensor data, which then is, and this is encrypted end-to-end, can be aggregated, on a server in the cloud on the back end, where you can then run, say, machine learning algorithms against this to build models, to see this huge collection of data from maybe all the hospitals, right? Within this system, aggregate this data, have AI routines running against it, building up projection models, which can then be pushed back down to the edge and operated on if you need modifications on your end devices. So it's very exciting.
Yeah, and it can be a two-way communication too, right? This is what I see can happen in the future. So then AI can also send the information to the sensors, and maybe that can be connected to the flow meters or to the oxygen. And we did talk about it in the previous call. So this is an advanced feature, but it is all possible because of your technology.
That is our end goal, is to be able to decrease some of the oxygen and resource consumption rates and the consequent costs that go along with that. And if we can use AI machine learning, or have a nurse and doctor from the nurse's station, or be able to optimize and adjust that patient's treatment protocol without even having to go into the room to stabilize them before the 30 seconds that they can get into the room and start that intervention sooner. Every minute that we save buys them a greater chance of recovery and survival, right? And no matter what we do, no cost or amount of money made can replace the life of the loved one. So we want to help intervene as quickly as possible, make the system as intelligent, robust, and secure. So not only can we intervene in real time, but in the future, if there's researchers that would like to partner and do retrospective studies, we can have this pool of data that is available, where they can then go back and see what worked, what didn't work, what were some of the parameters that led to people being more receptive or less receptive to some of the treatments. And this is some of the larger long-term thinking of what we can do by starting with the sensor suite, by adding some of these accessories, by taking care of people now, but looking into the future. Travis, could I ask you also, what is the range of LoRaWAN if we were to deploy this in Africa per se? And maybe you can use your example of what you're doing with education in the Congo as not only a way where we can get this out into more remote areas, but also how we can employ students in education to help scale and grow our collective efforts.
Absolutely. So we're working, Helium Systems is working with a group, One Planet Education. And this is out of Australia, Congo, throughout South Africa, in New York City, and a number of other countries, Liberia. And we're working with the department or the Ministry of Agriculture in a lot of these countries. And we're also partnering in a STEM partnership with schools, with what elementary all the way through high schools. And we're having students build agricultural sensors and that operate on LoRaWAN, on the Helium network. And we can deploy these in the field with professionals, in farmers. And in our experience, having these classrooms, having the education, built up in the classroom environment, these students are learning techniques for soil moisture, soil aeration, oxygen levels, and they're able to learn about farming, B, learn about how to intelligently farm and increase their productivity, what they're actually getting out of the ground. And then these students' code is actually running on these sensors in the field. And so they have dashboards set up where these students can see all the other different schools and all the other different countries, what's going on. They can see the sensor readings. They can have hydroponic setups within the classroom, or soil setups within pots in the classroom. This is pre-COVID. And so a lot of these setups are now in teachers' living rooms, but the students still have access to the data. They can still go, log in online and still see the results of these experiments that they had started months ago. And so, working with implementing this in the field, and these kids are able to work directly with the Ministry of Agriculture, out there, with farmers who are implementing this and seeing, hey, this code that I was working with is actually making a difference in my local community. So it's been very positive. We're getting a lot of great feedback there. But I think, seeing the cycle between the education, the STEM education, and the production deployment has been fascinating. So.
Wow, you can see how this technology will bring more innovation to the world, and the progress in some of the fields to be more efficient. And it's amazing, and I feel like medicine is one of those fields where you wanted to have that data, where you wanted to progress fast, because again, we're talking about saving life, and especially now during the COVID virus is very, is just spreading so fast. So speed is important, and for that we need that data so we can develop a better tools, better protocols to fight it.
Absolutely. And that's something I really enjoyed about working with this team, because it's a small, very nimble team. We're able to iterate very quickly and, see what works, get feedback, and then, just keep knocking this out, getting this in the field. And I think that's a true advantage of this team.
Are you looking for partners, for investors, for physicians who can do trials? Can you share that with the listeners? And I hope, you can connect with somebody who can help this technology to get to the patient.
We meet the physicians and the nurses that are willing to trial this out. We're looking for funders and investors that can take these pieces of sensor technology that we have here and help us make this on a larger scale and push this through to the people that need it. Beyond that, strategic partners too that are looking to collaborate, maybe share some of their expertise. We are ones where I think I'm so excited about working with this team and individuals like yourself, Arika, that have the passion, the expertise, and just that element of humanity, saying we're all in this together. How can we use what we know and what we do well to create a solution that is not going to only take care of us now, but well into the future, but also inspire the future generation of problem solvers to band together and work out solutions that will be impactful from this generation to the next and beyond. So all of those things really come into play. Having good partners like Helium and also Spark Fund Electronics too, who we are now building our US boards, and this is part of this global team and task force that we're building. Everyone's working together. So the technology may have started in Vietnam, but we're using it in Texas. We're using it here in New England as well, and hope to distribute this all across the country as quickly as we can.
We're going to learn a lot of new ways to treat the respiratory distress for the patients, to treat the infections. And this is the time where a lot of teams and teams from different fields are working on the same goal, how to save lives. Thank you.